Hey guys, happy Monday, happy June. You have 2 lessons left for the whole year. I first want to say I'm super proud of you. You guys have been doing wonderful all year. Actually, gotten, I think, more work from you guys than anybody else, so that's awesome.
Thank you.
So yeah, keep it up. We're almost there.
Are we there yet?
No.
Are we there yet?
Not yet.
Hey, are we there yet?
No.
Well, are we there yet?
No.
Are we there yet?
Yes.
Really?
No.
So here's the deal. You're going to have 2 lessons and 1 Google form left, and that's it.
That's all, folks.
Okay, so today and tomorrow, we're actually doing something that you use in real life.
I'm shocked.
Remember, you guys always ask me throughout the year, when am I ever going to use this? Well, this is something that's actually legitimate that you would use. Not that the rest of it's not, because you absolutely need it, especially for the rest of your math career, but this is a real life application. Okay, so our goal today and tomorrow is we're going to solve what we call compound interest problems. Keep in mind, everything is due by Sunday, so make sure you get it done.
I have to finish the race.
Okay, well, first off, we need to know how to change a percent to a decimal. So a lot of you know how to just move the decimal point, and that's perfect. Otherwise, though, if you struggle, if they give you a percent to change it to a decimal, just divide by 100. So if I want to change 40% to a decimal, I just do 40 divided by 100, and you get 0.4 or 0.40. If I want to change 5% to a decimal, again, I'm going to do 5 divided by 100. It is not 0.5. That would be 50%. It's 0.05. And if you don't believe me, take out your calculator, do 5 divided by 100, and you get 0.05. 6.5% looks like a decimal, except that it has that percent symbol with it. Anytime it has the percent symbol, you're going to take the number, divide it by 100. So 6.5 divided by 100 is 0.065. 3 3/4%. Well, first off, you should change this to a decimal. 3/4 is 0.75. So 3 3/4% is the same thing as 3.75%. And now that you have it out of that compound fraction, that mixed fraction, now you're going to do 3.75 divided by 100. And 3.75% is the same thing as 0.01375, right? So 3.75 divided by 100 is 0.0375. And that's important for today's lesson, is to know how to change a percent to a decimal. Okay. If I ask you to take a percent of an amount, so 10% of 100, all you're going to do is you're going to change your percent to a decimal, and then you multiply it to an amount. So 10% of 100, well, you're first going to change 10% to a decimal. So 10 divided by 100 is 0.1. And then you take 0.1 and multiply it by 200. So 0.1 times 200 is what? 20. So 10% of 200 is 20. 30% of 1,200. So again, I'm going to take the 30% and divide it by 100, and that's 0.3. And then I'm going to do 0.3 times 1,200, and you should get 36. Try it out. Oh, 360. Just kidding, 30%, not 3%. Silly Mrs. Cook. 15% of 80. So again, I'm going to change the 15 to 100, or 15 to a decimal. 15 divided by 100 is 0.15. And I'm going to do 15% of 80. And that should be 12. So 0.15 times 80 is 12. Okay?
Okay.
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 It's not quite that easy, but you need to know how to do that. So what we're going to do today is something called compound interest, okay? So a couple background things to know. First off, you're going to hear the words like the principal amount or the initial amount. That's how much money you either borrowed or invested. So a lot of times we talk about like buying a car or buying a house. The principal amount is how much money you're actually borrowing, that dollar amount. So if you buy a house for $300,000, the principal amount is $300,000. If you go to college and you get student loans and your student loans are $40,000, well, the initial or the principal amount is $40,000. Unfortunately, that's not the amount you end up paying back if you borrow money, okay? Because money, when you borrow it, the bank charges you interest. So interest is the charge for being allowed to borrow money. It is usually expressed as a percent, but we're going to have to change it to a decimal. That's why we practice that. So for instance, you might buy a house for $300,000, and if you have a nice interest rate, like 3%, right, then maybe over the course of 30 years, you end up, actually paying back $400,000. So you pay back the $300,000, but then you also pay back interest on top of it. Okay. Student loans. Okay. You might take, like I said, $50,000 out for student loans, but you don't pay $50,000 back. You might end up paying $100,000 back because there's interest charged on you.
Not fair.
The better your credit score, the more you pay your bills when you're older, the better the interest rate you get. And it also goes off of what's happening in the world. So those are things to keep in mind as you get older about interest rates. Okay. If it's not stated when you round money, you're going to round to the nearest hundredth. So money typically, and that's what we're dealing with a lot today, is money problems. So this would be the hundredth. So you'd look at the third spot and say, okay, is that going to change it? Is it going to keep it the same? So it's below a 5, it keeps it the same. Or is it 5 or higher and it bumps it a penny? Okay. So compound interest. This is interesting. And this is where a lot of things in real life actually have it. It's called compound interest. So it's not just interest on the principal, the amount you borrow, but it's interest on everything else. And depending on how long or how often it's compounded will depend on how much interest, extra money you end up paying back. So in other words, at the end of each year or maybe each month, the interest earned is added back to the original amount. So credit cards, sometimes they'll have compound interest every month. So they are essentially charging you interest on your bill every single month. It's a lot of interest. Okay. So we have some formulas that we can solve compound interest for. Yes, there are formulas that eventually you have to memorize, but you'll look at them again next year. These are also the same thing as what we call exponential growth or decay formulas. So they work the exact same way. So if you look at these two formulas below, we have y equals a, parentheses 1 plus r raised to the x, and y equals a, 1 minus r raised to the x. And we're going to talk about each of those variables. What do they mean? Notice a couple things. It's exponential because where's x located? Well, x is an exponent. It's raised up. So it's an exponential function. That's why you're going to grow interest really fast. So interest in a good way, like you might go to a bank and you deposit your money and they tell you that they're going to give you interest for using the bank. So you deposit money, so you'll gain money without doing anything. But interest in a bad way is like, again, when you buy a house, when you buy a car, student loans, things like that, it's going to grow really, really fast. Okay. So what do each of these variables mean? Well, y is going to be your ending amount. So however money you end up gaining or losing over time. A is what we call that principal amount, that initial amount you purchased it for. So the actual dollar signs you see in the problem. R is going to be your percent, which they're going to tell you, but you have to change it to a decimal. So for you, you're going to make sure you do R is going to be your percent divided by 100, and you use that number. And X is over time. So if it asks you, you buy a car for $25,000 at an 8% interest rate, how much money will you end up paying over the course of 8 years? Okay, so time would be whatever the problem's telling you. These are pretty straightforward. So you just have to plug and chug. So you want your calculator with you. Now I want you to look at the two formulas. What's the only difference between them? Well, the growth one has a plus sign, and the decay one is you have a minus. Typically, you use the growth because the money is going to be gaining. So when you, when you buy a house, that you're going to end up paying more. So that would be growth. Something that decays, though, we talked about buying a car, how much you might pay, but the value of the car decays over time. Actually, it decreases the second you drive it off the car lot. So if you buy a brand new car for $25,000, you could drive it down the road, and in 2 weeks, it's only worth $22,000. So you've lost $3,000 in like 2 weeks' time.
No way, Jose.
Because the amount of what you paid for it, it depreciates or decays. Okay. So why is there a 1 in the parenthesis? Well, the 1 is because we changed that R, that percent, to a decimal. So the 1 has to deal with 100%. So it's out of 100%. That's why it's in there. Okay. Some words for growth. So if you see interest or increase, you know you're going to use the growth formula. If you see depreciates or decreases, you'll use the minus. See, the only difference between the two formulas is that growth has a plus and decay has a minus. Everything else means the exact same and looks the same. So to use this, you're just going to write down the formula, identify each piece, and plug and chug. So this says you deposit $1,000 into a savings bank that has compound interest rate of 10% annually. So that's yearly. Calculate the money earned after 4 years. Also, if you find a bank that has a compound interest rate, they give you 10% annually, you let Miss Cook know, because I'm going to put my money in that bank, okay? So first off, your money's going to grow. So this is growth. We're going to use the formula y equals a parentheses 1 plus r raised to the x. When you do your homework tonight and you do your Google form, you're going to want that formula with you, all right? A is the initial amount. So how much did you deposit? Well, you deposited $1,000. R is your percent. So it's 10%, but you need to change it to a decimal. So you're going to divide that by 100. And in the formula, you're going to use 0.1. X is the time. So they want you to know after 4 years. And Y is what you're looking for. So you don't substitute in there. You're going to get Y equals, A is 1,000. Parentheses 1 plus, I'm not going to use 10, I'm going to use the 0.1 that we found, and we're going to raise it to the 4th. So in your calculator, you can plug that in one step, 1,000, parentheses 1 plus 0.1, which is the same exact thing as 1.1 raised to the 4th, however you want to write it. So I'm going to do 1 plus 0.1. And then raise it to the 4th, not times 4th. Use that caret key. So above division, you've got that key on your calculator that looks like this. That's when you need to do. You need to raise it to the 4th, okay? And I get y equals 1,464.1 or 0.10 because we're talking about money. So in other words, in this bank, you deposited $1,000. You didn't put any more money in, okay? But because they give you 10% annually, after 4 years, you now have $1,464.10. So for doing absolutely nothing besides putting your money in there, you've gained $464.10. Pretty good deal. Plus nice and easy for math. Let's look at this one. Raul needs $200 to start a snow cone stand for the hot summer. He's going to borrow the money. He's going to borrow the money from a bank that charges 4% interest a year at the end of each year. How much money will he owe if he waits 3 years to pay back the loan? Well, this is still growth because he's going to have to owe more money. So it's y equals a parentheses 1 plus r raised to the x. A is the $200 he gained or he initially needs that he borrowed. R is the 4%, but we have to change it to a decimal. So divide by 100. So it's 0.04. And he's going to pay it back in 3 years. So x is 3. Y equals 200, 1 plus 0.04, raised to the 3rd, plug it in your calculator in one step, 200, 1 plus 0.04, raised to the 3rd, and y equals 224.972. So as far as money goes, that 2 is not going to change that 7. So y equals $224.97. So Raul, instead of just paying back the $200, after 3 years, he owes $224, almost $225. That's it. It's as easy as it is. You need your calculator. You need to know that it's raised to the time and don't multiply it, okay? And go from there. So this one says you deposit $1,500 into a savings bank that has compound interest rate of 6 3/4 annually. Calculate the amount of money you have at the end of 5 years. So again, this is growth. Y equals A, 1 plus R raised to the X. A is the money, so you put in 1,500. R is the percent, so that's 6 3/4%. Now remember, when we started, I said you should first put that as a decimal. So 3/4 is the same thing as 0.75, so this is 6.75%. You're going to divide that by 100, and you get 0.0675. So that's the number you'll use. That's the R you want to use in your formula. And again, X is the time, and they said at the end of 5 years. Plugging into the formula, Y equals A, which is 1,500. 1 plus, because you're gaining money. We're going to use the 0.0675 here. Raise to the 5th, and again, make sure it's raised up there to the 5th. Once you have it plugged in, use your calculator, 1,500, parentheses 1 plus 0.0675, raise it to the 5th, and again, I put it all in one step across the board, and I get Y equals 2,079.364. That 4 is not going to change that 6, so Y equals $2,079.36. So again, he started with $1,500. After 5 years, he's got $2,079. So he's gained like just over $500. Good deal. Let's look at this one. Jack has $500 to invest. Think Bank offers an interest rate of 6% compounded annually. How much money will he have after 10 years? Same thing. Y equals A, parentheses 1 plus R raised to the X. A, the money. He put in $500. R, the percent, 6%. Change it to a decimal, so divide that by 100. We're going to use 0.06. Use that one. X is the time. They want to know how much will he have after 10 years. So Y equals A is 500. 1 plus 0.06. Raised to the 10th. Plug it in my calculator. Raised to the 10th. And at the end of 10 years, he has $895.42. So again, it took 10 years, but he didn't put any more money in there. He put $500 in, and then because there was a good interest rate on it, he now has $895.42. Let's look here. A bank is advertising that new customers can open a savings account with 3 3/4 interest rate compounded annually. Robert invests $5,000 in an account at this rate. If he makes no additional deposits or withdrawals, find the amount of money he will have to the nearest cent after 3 years. Same thing we've been doing. His money is going to grow. So it's Y equals A, 1 plus R raised to the X. A, he deposited $5,000. R is 3 3/4%. We're going to first change that 3 3/4 to 3.75%. Now divide it by 100, and that equals 0.0375. And remember, that's the number we want to use in the formula. X is the time. So it says if he makes no additional deposits or withdrawals, find the amount of money he will have to the nearest cent after 3 years. So X is 3. Y equals 5,000. 1 plus 0.0375 raised to the 3rd. In my calculator, 5,000. Parentheses 1 plus 0.0375 raised to the 3rd, and after 3 years he has $5,583, and look, it's 857. So my rounding now this time, that 7 is going to change that 5 to a 6, so he has $5,583.86. And there's your final answer for number 6. I don't think there was a number 5. That's it.
Yeah, baby, yeah!
Nice and easy. Doing the same stuff tomorrow, looking at them a little bit different, but it's a great way to end the year. Again, email, join the Google Meet on Friday. Everything is due by Sunday. And that is it for the year, guys. You have one lesson left.